Hi students, in this lecture we are going to discuss superposition of two SHMs. First let us see what is the principle of superposition. Suppose a particle is moving along x-axis. I am drawing here. Suppose a particle moving along x-axis under the action of a force F. Let x1 be the displacement. X1 be the displacement due to only force F. Suppose only force F1 is acting. In that case, displacement is x1. Now replace F1 with some other force F2. Then displacement of the same particle as a function of time is x2. Now, if both forces are acting simultaneously on the particle, then what will be the path, or you can say what will be the displacement of the particle? And that is given by x equal to x1 plus x2. This is according to principle of superposition. And this we can write only when restoring force is linearly changing with displacement. I am repeating. We can write the resultant displacement is equal to x1 plus x2 only when restoring force is linearly changing with displacement. So we are knowing that in SHM, a restoring force F equal to minus kx. That means a restoring force changing linearly with the displacement. That's why we can write x equal to x1 plus x2. Right. Now in this we are discussing two cases. Case 1, lines of oscillations are same with the same frequency. That means due to F1 it is moving along x-axis. Due to F2 also particle moves along x-axis only. Right. And that is the meaning of lines of oscillations are same. And frequency is same. You can see here omega and this also omega. That means it is frequency equal to omega by 2f. So both have same frequency. Now see, according to principle of superposition, x equal to x1 plus x2. Now simplify this. A1 sin omega t. Expand the next one. A2 sin omega t plus 5. A2 sin omega t cos 5. A2 cos omega t sin 5. Let us now rearrange this. A1 plus A2 cos phi into sin omega t plus A2 sin phi cos omega t. Let us take A1 plus A2 cos phi equal to A cos alpha. A2 sin phi equal to A sin alpha. So by writing like this x can be written as A sin omega t plus alpha. I am repeating. By writing like this, by taking 192, we can write x as A sin omega t plus alpha. That means when you superimpose two simple harmonic motions having same lines of motion, then the resultant is also a simple harmonic motion along same line with the same frequency. That is what we can conclude from this equation. Okay. And coming to here, A stands for resultant amplitude. And that is given by, you can see from 192, we can take sum of the squares. Then we are going to get A square equal to A1 square plus A2 square plus 2A1 A2 cos phi. And if you want to find what is the value of alpha, Then we can take equation 2 by equation 1. Equation 2 by equation 1. That gives tan alpha is equal to a2 sin phi by a1 plus a2 cos phi. If you observe these two equations we have seen earlier, right? While learning vectors. So by seeing these two equations, we can say that we can take amplitudes a1 and a2 as two vectors. Phase difference between them is taken as angle between those two vectors. Then we can get the amplitude of the resulting simple harmonic motion. I am drawing a diagram here. So take it as this is A1 and this is A2. Sorry, taking their amplitudes as vectors and phase difference between them as angle between them. Then resultant of those two motions having amplitude that is A, and that makes angle alpha with A1 given by tan alpha equal to A2 sin phi by A1 plus A2 cos phi. So this is about case 1. Now see second case where lines of oscillations are perpendicular with the same frequency. That means because of only force F1, particle moves along x-axis. Because of only force F2, the same particle moves along y-axis. I am repeating. Because of the first force, particle oscillates along x-axis. Because of only second force, the same particle oscillates along y-axis. If both forces are acting simultaneously on that particle, then what will be the path of that particle? That means now we have to focus what is a path equation. And path equation means we have to connect x and y coordinates by eliminating time. See how to do that. So we have taken here y equal to a2, expand this one, sin omega t cos phi, cos omega t sin phi. In the place of sin omega t, write x by a1 from equation 3. Okay. In the place of cos omega t, we are writing square root of 1 minus x square by a1 square. In the place of cos omega t, square root of 1 minus sin square omega t. Okay, right. Now we are taking this cos phi x by a1 to left side. Then we are squaring on both sides. Then we are getting the path equation. See what we got. It is x square by a1 square plus y square by a2 square minus 2xy cos phi by a1 a2 equal to sin square phi. So from this equation we can say that motion always confined to a rectangle of sides 2a1 and 2a2. Let us now study the possible cases in this one. So first we have taken phi equal to 0. Either we can take this value in the path equation here, otherwise we can take in equation 3 and 4. If you take in equation 4, phi value 0, see what we get. I am writing here. So taking phi value 0, y equal to a2 . 2 Just a minute. Y equal to, it is A2 sine omega t. And we are having x equal to A1 sine omega t. So in the place of sine omega t, I am writing here. So from this, y equal to A2 by A1 into x. That means we can see y is proportional to x and passing through origin. So path equation is a straight line with a positive slope. I have written here. We can see that if y equal to 0, y equal to x2 by x1. Path is a straight line with a positive slope and motion is confined to first and third quadrants. Motion is confined to first and third quadrants. I will make a diagram here. So make one rectangle whose sides are 2a1 and 2a2. Now it is a straight line having positive slope. Therefore, it is a passing through first and third quadrants. So motion is like this. It is a simple harmonic about origin. It is simple harmonic about origin. And its amplitude is square root of a1 square plus a2 square. You can see that here. From origin to this corner, distance equal to square root of a1 square plus a2 square, right? Or we can write here a r bar equal to a1 I cap plus a2 j cap into sine omega t. If we differentiate this twice, we are going to get acceleration equal to minus omega square into r bar. I am repeating. If we differentiate r bar twice, we get acceleration equal to, I will write here, acceleration equal to acceleration a bar equal to minus omega square into r bar. So from this we can say that motion is simple harmonic with amplitude a1 square plus a2 square under root. So conclusion is that when we have two simple harmonic motions, lines of oscillations mutually perpendicular and there is no phase difference between these two, then path is a straight line. It is oscillatory motion and it is a simple harmonic motion. Amplitude is square root of a1 square plus a2 square. So we can give same conclusions for phi equal to pi. We can see the next one. We can have the same conclusions. So phi equal to pi, y equal to minus a2 by a1, y equal to minus a2 by a1 into x. That means again path is a straight line with negative slope. It is also SHO. Motion is confined to second and fourth quadrants. So conclusions what we have given for phi equal to 0, same conclusions. So in both the cases, path is a straight line, oscillatory and simple harmonic and its amplitude is square root of a1 square plus a2 square. Okay, right. Now take if phi equal to 90. That means if phase difference equal to 90, then see what we get. In equation 4, in equation 4, in equation 4, if you are writing phi value 90, it becomes cos omega t. Then what we can do here, see carefully once. I am writing here. When you take phi equal to 90, then x by a1 whole square y by a2 whole square equal to 1, right? If you are taking phi equal to 90, x by a1 whole square plus y by a2 whole square equal to 1. So this is equation of ellipse. That means elliptical path is a combination of two simple harmonic motions whose lines of motions are mutually perpendicular, having same frequency with different amplitudes. Okay, right. Now in this, if you take A1 and A2, both are same. Let us take A1 equal to 8. Then this equation becomes a circle, right? X square plus y square equal to a square. That means a uniform circular motion is taken as combination of two simple harmonic motions whose lines of motion are perpendicular, having same frequency with a phase difference of 90 with the same amplitude. Okay, or I can say the same point a different way. See carefully here. Draw one circle here. Draw two diameters. Let us call one diameter as x-axis and one diameter as y-axis. Let us take at one instant particle position vector of the particle makes angle theta with x-axis. So we are taking a particle following uniform circular motion. At one instant, the line joining the center and the particle means position vector makes angle theta with x-axis. Now see its projection. Its projection on x-axis. It is equal to x equal to r cos theta. And I can take theta equal to omega t. And its projection on y-axis. Its projection on y-axis is written as r sine omega t, where theta equal to omega t. That means uniform circular motion is a combination of two simple harmonic motions with the same amplitude, lines of oscillations mutually perpendicular, phase difference equal to 90, having equal amplitudes. Okay, that means projection of a particle in uniform circular motion is simple harmonic motion. This is about superposition of two SHMs. Let us solve problems basing on these two. Let's see these two problems. I have taken these two questions from H.C. Verma. Question 1 from object to 1 and question 2 from object to 2. See question number 1. Displacement of a particle is given by r bar equal to a into I cap cos omega t j cap sin omega t. What is the motion of the particle? So I have written here x coordinate, x equal to a cos omega t, y equal to a sin omega t. Here you can see lines of oscillations. They are perpendicular. One is x, one is y. Both have same amplitude, a and a. Both have same frequency. But one is a sine function and one is a cos function. That means phase difference is 90. Therefore, path will be a uniform circle. Okay, it is not SHM. Is a point clear? It is a uniform circular motion. Right? Okay. Let us see next question number 2. A particle moves in the xy plane according to the equation r bar equal to I cap plus 2j cap into a sin omega t. What is the motion of the particle? Here I can write x equal to, I am writing here, x equal to x equal to a sin omega t, y equal to 2a sin omega t. If you observe carefully, they have different amplitudes but same frequencies. One is along x and one is along y. If I am taking ratio of these two, x by y, this is a constant, right? Sin gets cancelled, it is a constant. That means x is proportional to y or y proportional to x. That means this is the equation for straight line. That means motion is now, it is a straight line, it is a periodic, it is also simple harmonic. So why it is a simple harmonic? See carefully why it is simple harmonic. I am writing here R bar is there. If you differentiate twice R bar, what we get? A bar equal to minus omega square into R bar. Check once, okay? If you differentiate that R bar twice, we are going to get A bar equal to minus omega square into R bar. That's why it is a simple harmonic. It is a straight line. Path is a straight line. Motion is a periodic and a simple harmonic. Okay.